So we're going to introduce to you guys rational expressions, and the way we're going to do that is we're going to have you look at fractions and equivalent fractions. So what I want you guys to do in the next 5 minutes is I want you to, either by yourself or with your team, I want you guys to multiply these fractions out. Now, just a reminder, when you multiply fractions, you do not need a common denominator. With fractions, you can multiply straight across, top with top, bottom with bottom. You're also not doing cross multiplication, okay? So these are not proportions. So take a look at what happens when we shift the numbers around, whether it's like moving the term sideways or flipping it up and down. And then be ready to share, because I will be calling on people and then after the next 5 minutes. Okay, so go ahead and get started, and then we'll check back in. Okay, let's quiet down. Let's come back together. So hopefully you were able to finish all of it. If you still have some stuff left over, that's okay. We can get that done right now. Now let's begin by looking at the first problem, problem A. We're multiplying 3 times 2 over 5 times 7. So what do we get for this question when we multiply across, meaning top with top, bottom with bottom? 6 over 35. Okay. Then we move on to problem B. In problem B, what we did is we took the first fraction and we flipped it. Instead of 3 over 5, now we turned it to 5 over 3. Let's see how that changes the result. Well, now we're doing 5 times 2 over 3 times 7, which does not give us 6 over 35, but gives us what instead? 10 over 21. All right. Then we have 2 over 5 times 7 times 3. So now we took the 3 and we took it away from the fraction. We turned it into a whole number. The difference with this problem is that a whole number has a different denominator. A whole number has a denominator of what? Of 1. So this would be 3 over 1. 2 times 3 is 6. 5 times 7 is 35. So we still get 6 over 35. Okay? All right. Now let's look at 2 over 5 times 3 over 7. So now we took the numerators and we switched their place. Instead of 3 over 5, now it's 2 over 5. And instead of 2 over 7, now it's 2 over 7. Does it change the result? Ultimately, it doesn't. 2 times 3 is still 6. 5 times 7 is still 35. Okay? All right. Next, we took 3 over 5 times 7 over 2, so that we not only did we flip sideways, but also up and down. 3 times 7 is 21. 5 times 2 is 10. So this is a completely different solution. 21 over 10. All right, then we have 2 times 3 over 5 times 7. So now we're taking that 2 and we're like pulling it out. It's like a whole number now. So whole numbers have a denominator of 1, and it gives us a result of what? 6 over 35. Okay. And we have 2 more. We have 2 times 3 over 5 times 1 over 7. So now it's like we're taking that denominator away. That 7 is like on its own, 1 over 7. Is it going to change things? No. We still get 6 over 35. And then finally, looking at problem H, we have 3 over 5 times 2 over 7 times 8 over 8. Now, you could do this a couple different ways. You could multiply straight across. 3 times 2 times 8, you'd get 48. 5 times 7 times 8 would get you like 280 or something. However, if you simplify before you multiply, what can we do with that 8 over 8? Turn it into a 1. Why is 8 over 8 equal to 1? It's a whole, well, how do we know it's a whole number? It's dividing by itself. 8 goes into 8 how many times? Once. So that is why whenever you get the same thing on the top and bottom, it turns into a 1. Okay? Because it fits into itself one time. And we get a solution of 6 over 35. Okay? So in this warm-up, we had a whole bunch of different combinations. And for 6 out of 8 of the problems, we got 6 over 35, even though the multiplication was completely different. Okay? Now, this is the cool thing about multiplication, that when you move the terms around, it doesn't change your answer. All right? It's the commutative property. You can move things around, and as long as you're multiplying everything together, it doesn't matter. 2 times 3 is 6, 3 times 2 is 6. It's the same thing, even though the order is different. That is a core thing of rational expressions, and that we're going to be using that to simplify things, right? Now, in today's work, we won't be doing a lot of simplification. That's going to be more for 802. Today, we're just going to be looking at equivalent expressions. Okay. So let me go ahead and read to you guys the instructions for the partner task, and then you guys can go ahead and get started. So here's the next task, and this is basically the last task of the day. We have a partner task, so you're going to work with only one other person at your table. Okay, figure out who that is. You're going to check your answers for each problem with me or with Miss Monica. And after we check your work, can you move on to the next question? All right. Read the instructions for each problem. And if you have any questions, let us know so that we can instruct you on how to do it. Figure out who your partner is at this time. If there are any groups of 3, then I can move some people around. Otherwise, I can just have you work with that group of 3 or something. All right. Go ahead and get started, you guys.